to Tennessee's At Home Learning Series for Math. Today's lesson is for all fifth graders out there, though all students are more than welcome to tune in. This lesson is the 12th in our series. My name is Miss Williamson, and I'm a fifth grade teacher in Tennessee schools. I am so excited to be your teacher today for this virtual lesson. Welcome to my classroom. If you didn't see our previous lessons, you can find them at the Tennessee Department of Education website, www.tn.gov/education. You can still tune in today if you'd like and you haven't seen the others, but it might be more fun if you go back and watch the other lessons first, as we'll be talking about some things we've learned previously. Today we'll be learning about using the standard algorithm and place value in order to multiply two-digit numbers by two-digit numbers. Before we get started, to fully participate, you will need paper, pencil, and a surface to write on, and the student packet for Math Grade 5, Lesson 12, which can be found at www.tn.gov/education. I'll give you a moment to gather your supplies. All right, let's begin. In fourth grade, you most likely learned how to multiply two-digit numbers by two-digit numbers using an area model that used partial products. We're going to do a quick review. Listen as I read this problem. Miss Sylvia has 12 weeks to train for a race. Over the course of 1 week, she plans to run 15 miles. If she continues this training, how many miles will Miss Sylvia run before the race? What do we need to do to solve this problem? Yes, we need to multiply 12 times 15. On your paper, can you write 12 times 15? In the previous lesson, I told you guys that I like to use the strategy of using the lines on my notebook paper to help me keep my work lined up and organized. This is just something that I like to do so that I keep everything in order. All right, so what is 12 times 15? Where do we begin? Well, first let's go back and review what we already know. Let's draw an area model. So go ahead on your paper and draw a box. We know that we can break apart our factors using place value. So 12 would break apart into 110 and 2 ones. So I'm going to break apart my box and I'm going to label the length 10 into 10 plus 2 is 12. Excellent. Now I need to break apart my other factor. Each one, the 1 is worth 10, the 5 is worth 15. This is obviously not drawn to scale because 15 is bigger than 10 and this side's a little shorter, but you get the idea. So I'm going to decompose 10 and 5. Is my length still 12, my factor? Is my width still 15, my other factor? Yes, it is. So now we need to multiply to simplify the expressions in the box. So let's look here. This box is what? 10 times 10. What about this box? This box is 10 times 2. And this box, 5 times 10. And this box, yes, 5 times 2. When I solve these are called what? Yes, they represent our partial products. What is a product? You were absolutely right. It's the answer to a multiplication problem. So why are these partial products? Yes, they're going to be partial products because the word partial means part. And what did we do to our numbers? We broke them apart. So in order to get our larger product, we're going to have to do what with our smaller products? Yes, we're going to have to add our partial products to get our final product. So 10 times 10 is 100. 10 times 2, 20. 5 times 10, 50. 5 times 2, 10. So let's add our partial products. 100, 120, 130 plus 50 is 180. So remind me, these are called, that's right, partial products. And what do I do with my partial products? Yes, we add them. All right, let's do another one. We're going to do it using, we're going to do one using partial products, but we're not going to use the area model. Okay, so on your paper, please write down 37 times 24. 37 times 24. So let's begin, remember, in the ones place. So first, we're going to multiply the 4 times the digit in the ones place. 4 times 7 is 28. So we're going to write 28. Now we're going to multiply the 4 times the 3. But what's the 3 worth? Yes, the 3 is worth 30. So technically I'm doing 4 times 30. What is 4 times 30? Yes, 120. So the product of 4 times 30 is 120. Fabulous work. Now, where do we go from here? This is a little different than our last lesson because the last lesson we only had a digit in the ones place. So this time we're still working in our second factor, but we're working in the tens place. What digit is in the tens place of our second factor? Yes, the 2. Excellent work. So now the 2 needs to go to the ones place. So that's 20 times 7. 20 times 7 is how much? 140. So that's another partial product we will add here. And now, just like with our when we were in the ones place, we visited the ones and then we multiplied by the tens. Well, we're going to do the same thing in the tens place. We multiplied by the ones. Now we're going to multiply by what? Yes, the tens. 20 tens, 20 tens, I'm sorry, 2 tens, which is 20, I apologize. 2 tens, which is 20, times 3 tens, which is 30, equals what? Yes, 600. So we need to include 600 on our list of partial products. And remember, from our area model, what do we do with those partial products? You're right, we find the sum. So we're going to add 8 plus 0 plus 0 plus 0 is 8. 2, 4. 4 plus 4 is 8. 6, 7, 8. So our sum is 888. And we did that by finding partial products. Do you notice how, let me grab this paper, how we ended up with 4 partial products here? And when I use my area model, I also ended up with how many? 4 partial products. Excellent conclusion to draw. So, do you think we will always have 4 partial products when we're multiplying a 2 by 2? Well, let's move on to the standard algorithm to see if we get the same answer. We're going to look at that same problem again. So come over to the side in your paper and let's rewrite that. 37 times 24. 37 times 24. Remember, we're working from the right to the left, and we start with our smallest value numbers first. In our problems, what value has been the smallest? Yes, the ones place. That's excellent. From the ones place, we then move to the tens, hundreds, and even the thousands if our numbers were bigger. What did we have to do? What did we have to do sometimes when we were multiplying? Excellent. We might have to regroup. We may have to regroup tens. We may have to regroup hundreds. We may even have to regroup thousands. So we need to keep that in mind. So let's begin. Let's start with the ones place. The ones place, what digit is in the ones place of our top factor? 7. Excellent. So we are going to do 4 times 7 first. What is 4 times 7? Yes, 4 times 7 is 28. Remember, we're going to write an 8 in the ones place, and we're going to regroup a 2. That 2 means 20. We regroup it over the tens place because it's worth 20. Now that we've regrouped, we're ready to do what? We need to multiply the 4 times the tens place. Okay, so 4 times 3 tens. What is 3 tens worth? 3 tens is worth 30. So 4 times either 3 tens, or we could think of it as 4 times 30 equals, that's 12 tens. 12 tens would be 120. So, but I can't forget what? I can't forget that I regrouped 2 tens. So 12 tens plus 2 tens is 14 tens. And so we get 14 tens. So I want you to notice that that one was, and we get the 14. 4 times 3 was 12 tens plus 2 is 14. Fabulous. We had to remember to regroup to get the 14. Now we're ready to move over to the 2 in the bottom factor because the 2's in the tens place. So 2 tens times 7 ones equals what? Or 20 times 7 equals 140. Very good. And so in the ones place, how many do we have? We don't have any. In the tens place, we have how many? We have 4. And so I would need to regroup what? Excellent. I would need to regroup a 1. Okay, so let's keep going. So now my 20, the 2 in the tens place, has to go to the top factor's tens place. So 2 tens times 2 tens times 3 tens. 2 tens times 3 tens equals 600. But we regrouped how much? We regrouped a 1. So instead of 600, we have 700. Now remember, what do we do with our partial products? That's right, we add them together. So let's do that. 8 plus 0 is 8. 4 plus 4 is 8. 7 plus 1 is 8. Do you notice that we got the same answer using partial products and using the standard algorithm? Let's review. So far, we've multiplied 2-digit by 2-digit numbers using an area model, using partial products, and using the standard algorithm. We need to remember that when we're multiplying, we work from the right to the left. So we multiply by our smallest place value first. In our problems, that has been what place? That's right, the ones place. Then we can move left to work with the tens place, the hundreds place, and even the thousands. What did we have to do sometimes while we were multiplying? We did. We had to regroup. Sometimes we regroup tens. We had to regroup hundreds. And in the future, we may even have to regroup thousands. Let's continue practicing our multiplication. Listen to this problem and write it down. 47 times 23. What is 47 times 23? Where do we need to begin? Well, let's start this time by drawing an area model. Okay, so we draw a rectangle. I'm going to move my paper over. Let's draw a rectangle. Okay, now remember, we can break apart each number. How could we do that? That's right. We could break apart 47 into 40 plus 7. And we could break apart 23 into 20 plus 3. Now we can write our expressions in each box. So what would the expression be for each box? 40 times 20, 20 times 7, 3 times 40, and 3 times 7. Excellent. But we'll need to simplify or solve the expressions to help get our final product. So why don't you help me? Solve your expressions in the boxes and see what you get. All right, check your work with mine. Did you get 800, 140, 120, and 21? I might draw that a little bigger. Didn't leave myself enough room. Fantastic. Now, what do the expressions in the smaller rectangles represent? Great job remembering our new vocabulary. They represent our partial products. So what do we do with those partial products? Absolutely. We can add our partial products to get our final answers. So we're going to add 800 plus 140 plus 120 plus 21. Solve those. Let's see what you get. Did you get 1,081? Did you get 1,081? Excellent. Now we're going to use the same problem, but we're going to try solving it using partial products. Are you ready to work through this together? You may want to rewrite so you have more room. I'm going to come over here and rewrite it for my partial products. Excellent. So let's begin in the ones place of our second factor. That's a great question. Where is the second factor? That's right. 23 is our second factor. It's the bottom factor in the equation. All right. So first we start in our second factor and we multiply the 3 by the ones place. What's the ones place in 47? The 7. Excellent. So the first thing we're going to do is 7 times 3 equals 7 times 3 equals, yes, 21. So we will write 21. Now we need to multiply the tens. So 3 times 4 tens or we can think of it as 3 times 40 equals 12 tens, or 12 tens is worth how much? 120. Excellent work. All right, so we're going to write down our next partial product, 120. Can you finish from here? I'm going to pause and let you find the other two partial products. You can do it. Let's check your work. Did you multiply the 2 tens times 7, 2 tens times 7 to get 14 tens, or 20 times 7 to get 140? Fabulous work. Then, did you multiply your 20 or 2 tens times 4 tens and get 800? Excellent. And remember, what do we have to do to get our final product? That's right. We have to add up our partial products. And so did you end up with 1,081 as your end product? Excellent work. You're really getting the hang of this. Do you see a connection between the partial products and the area model? Fabulous. You noticed that they were the same. We get the same end product. Now, can you try the standard algorithm for 47 times 23 on your own? 47 times 23 on your own. I'm going to give you a moment to work this problem out on your own, and then let's see how you did. All right, let's begin. You should have started in the ones place. And so 3 times 7 is 21. So we put down the 1 and we regroup the 2 because the 2 was worth 20. So we regroup it to the tens place. Now we're going to go to the tens place. 3 times 40, or 3 times 4 tens, is 120, plus 2 is 140. So 40 times 3 equals 120. Oops, but I have to remember to add the 2 I regrouped to get 140. We already had a 1 in the ones place. I'm going to rewrite that. It's a little messy. Okay, fabulous. Thank you for following along. Now, what are we going to do? You should have multiplied the 2 tens times the 7. 2 tens are 20 times 7 is 140. So we are going to write 0, 4, because we have our ones, we're in our tens, we need to regroup. 2 or 20 times 40 is 800, plus the one I regrouped is 900. And these are partial products. And you know what I did? I moved from this one all the way back up to this one. That's okay. We'll make it work. And so what do we do with our partial products? You're right. We have to add them together. 0 and 1 is 1. 4 plus 4 is 8. 9 plus 1 is 10. So 1,081. Our final answer was 1,081. It is so exciting to know that we can multiply in so many different ways and get the same answer. If you are having a hard time with one method, you can switch and try another. Math is so amazing in that way. You've worked really hard today. Give yourself a pat on the back. Let's do another one. Let's do some more practice. Are you ready? On your paper, write 16 times 22. Since the standard algorithms is the most new for fifth graders, the most new strategy for fifth graders, why don't we start there? Are you ready? So remember, we're going to start in our ones place. Our 2 is going to go to the ones places of our top factor. 2 times 6 is 12. 2 times 6 equals 12. Okay, so I'm going to put down a 2. I'm going to regroup a 1. Now my 2 needs to go where? Now the 2 has to go to the tens place. Great work. So 2 times 10 equals how much? Because the 1, remember, is worth 10. 20. But I can't forget that I regrouped a 10. So 20 plus 10 is 30. So I end up with a 3. Excellent job. Now I do what? What comes next? Did you say that I move over to the other 2 in the bottom factor? Yes, but we got to remember that 2's not worth 2. How much is that 2 worth? It's worth 2 tens or 20. So 20 times 6. 20 times 6 equals how much? Yes, it equals 140. Okay, so I'm going to put down the 40 and I'm going to regroup a 1. Got to regroup the 1. Now I'm do what? 20 times what? What's this 1 worth? Excellent work. That 1 is worth 10. So 20 times 10 equals how much? Did you say 200? So we said 200 plus the 1 we regrouped is how much? 300. And so what do we do with our partial products? That is absolutely right. We add them. 2 plus 0 is 2. 3 plus 4 is 7. 3 plus nothing is 3. So our final product is 372. I hope some of you recognize that I made a mistake. What is 20 times 6? Yes, it's not 140. It's 120. And so our product is messed up because our partial products were off. So that's where attention to precision is so important. So I'm going to change that to a 2. And so we should have ended up with 352. It's always good to double check yourself because everybody is capable of making mistakes. Today we reviewed multiplying 2-digit by 2-digit numbers. I hope you're seeing some connections among the different ways. After the video, you will have some practice problems to do on your own. Good luck. I know you'll do your best. I will show you your independent practice problems now, or you can find the practice problems for the lesson posted at www.tn.gov/education. Students, I've really enjoyed our time together today using various strategies to multiply with a focus on 2-digit by 2-digit numbers. Thank you for inviting me into your home, and I look forward to seeing you in our next lesson in the Tennessee at Home series. Bye!